In problem number 40, we're asked to find the domain of g of f of x. So g of f of x. And there are two areas we want to look at when we're trying to figure out the domain of a composite function. We want to ask ourselves, what's the domain of f of x? Well, the domain is, look at f of x, it's a linear function, and the domain therefore is all real numbers. And then we want to figure out, so we don't have any exclusions, in other words. So we want to look for exclusions two places. First, the exclusions for the inner function, and we have none. And therefore, we want to figure out what g of f of x is. G of f of x equals g of x minus 2. And we plug x minus 2 in for x into the function g. So we have 1 minus 2 times the input, and we get 1 minus 2x plus 4, which is 5 minus 2x, which is also a polynomial function, so therefore the domain is all real numbers. So we're looking for exclusions in the inner function and then the exclusions in the outer function after plugging in the f of x as the input into the outer function. So the domain is all real numbers, and that's the domain of f, let's see, g of f of x. Okay, so that's that. And then let's see about g of x. Well, anytime you replace or the inner function is a polynomial and the outer function is also a polynomial, you're going to get a domain of all real numbers. So basically g of x, we have no restrictions on g of x, and then when we replace x with 1 minus 2x, we get another polynomial function, so therefore the domain is all real numbers. So we don't really need to simplify that. We can see it's a polynomial function. Hopefully we can. Anyway, let's scoot on down to number 42. Now, 42, we get one function that's a polynomial. F of x equals x squared plus 4. And then we have g of x is the function square root of x minus 2. And we're asked again for part B to find the domain of g of f of x. Well, since f of x, being the inner function, is a polynomial, we see we have no exclusions on x. So now all we're doing is trying to figure out if, after plugging in f of x into our g function, we ask ourselves, are we going to get any exclusions? So notice, again, that since g of x, do this here, g of x is radical x minus 2, whatever the input is has to go there. So we create a function. And let's simplify this. So we will probably have, well, I guess we're not. If we simplify under the radical, we get radical x squared plus 4. And what we really need, if we have any exclusions at all, we need to make sure that x squared plus 4 is greater than or equal to 0. And for what real numbers is this inequality true? Well, understanding that x squared plus 4 can never be even equal to 0, it has to be always positive, we would see that this is always true. If this statement, which it is for all real numbers, it's always true, then there are no exclusions on what x can be. So therefore, the domain of what is it? G of f of x is all real numbers. So there are no exclusions. If we find an exclusion, great, then we don't have a domain of all real numbers. But here there are no exclusions. Let me see if I can squeeze D in there. And D, we're trying to figure out the domain of g of x, g of g. And so g of x, now that the domain of g of x, if you look here, we need to make sure we're only using values of x that are that would cause x minus 2 to be greater than or equal to 0. So in other words, x has to be greater than or equal to 2. So that's our this is our restriction on what x has to be. So we're excluding all values of x that are less than 2. And so when we replace g of x with radical x minus 2, and we replace x then in the function g, this is getting confusing, we get radical x minus 2 minus 2. So now we have this little, looking for our next set of exclusions, we have this under the radical, and we always know that under the radical has to be greater than or equal to 0. So we have this new inequality that we have to solve, and we solve that by adding 2 to both sides, and we get the square root of x minus 2 has to be greater than or equal to 2. And how do we solve this? Well, if we want to get x by itself, we're going to have to square both sides, and squaring both sides we get the absolute value of x minus 2 has to be greater than or equal to 4, and we get, so this goes way back to Algebra 2 when we learned how to simplify and solve inequalities with absolute value. This says that either x minus 2 has to be greater than or equal to 4, or x minus 2 has to be less than or equal to negative 4. But if we solve this second one, we add 2 to both sides, we get x is less than or equal to negative 2. Well, we already are only allowed to be using x values that are greater than or equal to 2 from our first set of exclusions. So we don't even consider that, and because we weren't even allowed to use those values anyway. So if we add 2 to both sides here, we get x is greater than or equal to 6. So this is our new exclusion, so this is our new restriction on x, which excludes all values to the left of 6. So therefore, we identify the most restrictive interval. So notice that we initially were only allowed to plug in values of x that were greater than or equal to 2, but now we're only allowed to to use x values that are greater than or equal to 6. So we say, therefore, the most restrictive domain for the domain of g of x is all real numbers x such that x is greater than or equal to 6. That's a tough problem. If you got that, good job.